Last week, we covered the news of India's historic moon mission, Chandrayaan-3, which made history as the first mission to land in the lunar South Pole region, making India the fourth country to successfully land on the moon. We explained what Chandrayaan-3 is and how it works and how it landed, and the difficulties it faces. We also explained why the lunar South Pole region is very interesting and important for lunar exploration. But that was not the end of the story. Chandrayaan-3 has been busy exploring and discovering new things about the moon and its South Pole mystery. And now, we have some amazing new images and updates that we will cover in this video. We will show you what Chandrayaan-3 has achieved and found so far, and explain why these findings are important and what they can reveal about the moon and its history. Let's get started. Before we explain this amazing image of Vikram lander on the moon surface, let's watch this stunning video of the Pragyan rover descending to the lunar surface, as observed by the Vikram lander. This video was recorded by Vikram's imager camera, which is mounted on its top side. This camera is used to help the Vikram lander monitor its surroundings and communicate with the Pragyan rover. The video shows Pragyan rover rolling down from a ramp that extends from Vikram's belly. You can see how Pragyan rover slowly and carefully moves towards the moon's surface, while Vikram lander watches over it. In the background, you can also hear some beeps and voices from the Mission Control Center, which indicate the status and progress of the descent. But they don't have instant control over the lander or the rover, as it would take around 1.3 seconds to send a command from Earth to the moon, and another 1.3 seconds to receive a response. That's why the lander and the rover are pre-programmed to do this operation autonomously, using their onboard computers and sensors. They have to rely on their own intelligence and skills to land and deploy safely on the moon. This video is proof of how successfully the Vikram lander and Pragyan rover worked together as a team to achieve this historic feat. After successfully descending onto the lunar surface, the Pragyan rover took an incredible image of the Vikram lander standing on the moon's surface using the Pragyan navigation camera, which is mounted on its front side. We have another video that shows how the Pragyan rover navigates and avoids hazards on the moon, but we will talk about that in the next section. For now, let's focus on this amazing footage of Pragyan rover descending to the lunar surface. As you see, the image shows Vikram lander standing upright on 4 legs on a flat area near a small crater. You can see its main engine at the bottom, which was used to slow down its descent and soft land on the moon. This image is proof of India's successful landing on the moon, which was not an easy task. In fact, only 3 other countries have done it before: Russia, the USA, and China. Landing on the moon requires precise timing, navigation, and control of speed and altitude. Any error or malfunction can result in a failure or a crash. That's why landing on the moon is often called the hardest part of any lunar mission. But this image is not only a proof of success, it is also a tribute to a legend, Vikram Sarabhai, who is considered the father of India's space program. He was a visionary scientist who founded the Indian Space Agency in 1969 and initiated many space projects in India. He was also a pioneer in fields such as nuclear physics, cosmic rays, meteorology, education, industry, and social development. The next one is actually another video of the Pragyan rover maneuvering on the moon's surface. This video was recorded by the Pragyan rover using its navigation camera. The video shows the Pragyan rover moving on the moon using its 6 wheels, which are powered by solar energy. The Pragyan rover is the main instrument of the Chandrayaan-3 mission. It is designed to explore the lunar South Pole region and conduct various experiments and measurements. It can travel up to 500 meters from the Vikram lander, and it can communicate with the Vikram lander and Earth using radio signals. But moving on the moon is not as easy as it sounds. Pragyan rover faces many challenges while moving, such as low gravity, uneven terrain, dust particles, and extreme temperatures. Let's see how Pragyan rover deals with these challenges. First, low gravity. The gravity on the moon is only about 1/6 of that on Earth. This means that Pragyan rover weighs much less on the moon than on Earth. This also means that it can jump higher and farther, which means that it has less traction and stability than on Earth. To overcome this challenge, the rover has a special suspension system that allows it to adjust its height and tilt according to the terrain. It also has a speed limit of 1 centimeter per second to avoid losing control or flipping over. Second, the uneven terrain on the Moon is very rough and rocky, with many craters, hills, and valleys. This makes it hard for Pragyan rover to find a smooth and flat path to move on. To overcome this challenge, Pragyan has a sophisticated navigation system that uses sensors, cameras, and algorithms to map the terrain and plan the best route to avoid obstacles. It also has a hazard avoidance system that can detect and avoid potential dangers, such as large rocks or steep slopes. Third, dust particles. The dust particles on the Moon are very fine and sticky, and they can cover everything on the Moon surface. This can affect the performance and functionality of Pragyan rover's instruments and components. For example, dust particles can block the solar panels that provide power to the rover, or they can damage the cameras that provide vision to it. To overcome this challenge, the rover has a dust protection system that uses brushes, blowers, and heaters to clean and protect its instruments and components from dust accumulation. Fourth, the extreme temperatures of the Moon vary widely, depending on whether it is day or night, or whether it is exposed to sunlight or shadow. It can range from -156 degrees Celsius at night to +121 degrees Celsius during the day. This can cause thermal stress and damage to the Pragyan rover's instruments and components. To overcome this challenge, the rover has a thermal control system that uses insulation, radiators, and heaters to regulate its temperature and keep it within safe limits. As you can see, Pragyan rover is a very smart and resilient machine that can cope with the harsh conditions of the Moon. It is also a very curious and adventurous machine that can explore the unknown regions of the Moon and discover new things about our natural satellite. The third one we have here is a graph of the chemical composition of a sample of lunar soil analyzed by the Pragyan's laser-induced breakdown spectroscopy, or LIBS instrument. It shows a bar chart of the elements present in the sample, with their relative abundance in percentage. LIBS is one of the main scientific instruments on the rover. It is used to determine the chemical composition of lunar soil samples by exposing them to intense laser pulses. The laser pulses generate an extremely hot and localized plasma, which emits light. The instrument picks up the light and analyzes its wavelengths to identify the elements present in the sample. One of the main objectives of this mission is to study the lunar soil composition in the South Pole region, which is different from other regions of the Moon. The lunar soil composition can tell us a lot about the origin and evolution of the Moon, as well as its geological processes and activities. Surprisingly, the results of this analysis showed that the lunar soil in the South Pole region contains high amounts of sulfur, which is unexpected and unusual. This element is important for life, as it is part of many biological molecules, such as amino acids and proteins. It is also a key ingredient in volcanic activity, as it is often found in magma and lava. It can also indicate meteorite impacts, as some types of meteorites contain sulfur. The presence of element in the lunar soil in the South Pole region suggests that this region may have had some form of life, volcanism, or meteorite impacts in the past. This is very exciting and intriguing, as it can change our understanding of the Moon and its history. It can also open new possibilities for future exploration and colonization of the Moon. The fourth update we have for you is the temperature of the Moon's surface measured using the Vikram lander's CHASTE instrument, which measures the temperature of the Moon's surface. It stands for Chandra's Surface Thermophysical Experiment, and it is one of the scientific instruments on the Vikram lander. It is used to measure the temperature profile of the lunar topsoil around the pole to understand the thermal behavior of the Moon's surface. By measuring the temperature of different depths of the soil, CHASTE can create a thermal map of the Moon's subsurface. Also, this is one of the main objectives of the mission, especially in the South Pole region, which is different from other regions of the Moon. The results of the CHASTE measurement showed that the temperature of the Moon's surface and subsurface in the South Pole region varies from -156 degrees Celsius at night to +121 degrees Celsius at day. This confirms that the South Pole region is one of the coldest and hottest places on the Moon, and that it poses a great challenge for survival and exploration. We think that Chandrayaan-3 is a remarkable contribution to lunar exploration, and that it deserves our admiration and appreciation. We congratulate India for its success and innovation in space. If you liked this video, please give it a thumbs up, share it with your friends, and subscribe to our channel for more videos about space and science. And don't forget to comment with your thoughts and questions about Chandrayaan-3. We would love to hear from you. Thank you for watching this video, and stay tuned for more.